So you've recently installed some French cleats, or you're thinking about it and want to know what kind of fittings you can use to organize your tools. If that describes you, then you're in the right place. I recently installed a couple of different sizes of cleat into my workshop and storage space, following which I've been designing and building a range of cleat fittings that I'm going to walk you through during this series. The beauty of cleat fittings is that you can build them in many different ways. The approach that I'm going to focus on is a modular design which uses a range of different bracket shapes that each work with different use cases. This bracket approach and integral cleat hook has a number of advantages over a traditional method where you fit a mirrored cleat to the back of your fitting. First advantage is that in a lot of cases you will use less material with the brackets. There is also no need to rip 45-degree bevels into your ply sheeting each time you want to make a fitting. Another useful design feature is that vertical support can be built right into the bracket. This removes the possibility of tipping and again saves material versus using a support bar, which is typical in a traditional method. You can also include a notch in your bracket design that allows easy locking of the cleat with a dowel or a cutout plug. This is great to properly secure the cleat fitting so it can't fall off when you're taking off a tool. Importantly, if you have a small cleat wall, brackets more often than not will give you a smaller vertical footprint, saving space for more tool fittings. Now let's deal with the obvious drawbacks. First is that to make up these brackets, you need access to CAD design software, and second, you need access to a CNC machine or a powerful laser cutter. On the software side, I'm using Fusion 360, which is free for personal use. The app has a bit of a learning curve to it, but after only a few hours, to be honest, making models for parts like these will be pretty simple for you. For CNC, I'm using a Shaper Origin handheld CNC, which is for sure an investment, but a great and flexible tool for on-site work or in small shops like mine with limited floor space. That said, if making parts like these brackets isn't for you, don't worry, I make and sell a range of these brackets on my Etsy shop with worldwide shipping. Feel free to check out the link to my shop in the description. Now on to our 5 fittings. First up, we have the most basic type of cleat fitting, which I just call a flat cleat. Here we use a pair of these small brackets and combine with a small vertical face that is the same height as your wall cleat and is as wide as is needed for the application. The main way that I've used these cleats is where you simply want a flat surface to attach a pre-existing tool bracket. For example, I've got a range of tools from Bench Dogs, which I use regularly, and most of their range come with a wall mount. I have a couple more wall mounts I want to put up, and I can use them to show you the simple process. First, we grab some scrap ply and set up the Shaper Origin to cut out the brackets. You can use a roughing pass here with your shaper, but personally I don't bother for speed. We then do a quick face sanding and edge cleanup either by hand or using a spindle sander if you have one. I make up all my brackets to accept a 16mm diameter plug, which in turn are made up from scrap ply on the drill press using a plug cutter. With brackets good to go, we just need to make up the face piece by dimensioning more scrap ply to a height that matches our wall cleat and a width to work with our holder. Next up is assembly, where I use a small amount of wood glue and combine with CA glue for instant connection. Here is one easy way to bring the parts together in the right place. Having added wood glue and CA glue to the insert, take the insert and offer it to the wall cleat using your fingers to position it so it's flush at the top and the bottom of the cleat. Then, having applied activator to your bracket, hook it onto the cleat and make sure it's properly seated before bringing the two pieces together. The CA glue will grab almost immediately as long as you have been fairly sparing with your wood glue. This method will give you an accurate placement every time. You can simply repeat the same process for the other bracket. Lastly, if you want extra security, you can use a couple of brad nails on each end. With the cleat fitting done, we can attach our tool mount to the insert, then get it up onto the wall. Another use case for the flat cleat is creating a hanging peg, where you might have, say, a spirit level or a set of winding sticks or something similar. Pegs here can be made of dowel or aluminium shelf pins if you have any lying around. All you need to do here is to drill a hole the same diameter as your pin, either straight in or at a slight angle if you need to, and then you're done. Next, we have the mini mag wall. This is simply a taller face piece attached to an elongated set of brackets. Here we start by measuring up for the face, where it helps by laying out the tools that you want to fit on the bench. You can then easily measure for your cut. The brackets we make in exactly the same way, just using a different cut file, where the height of the face determines the design of the bracket. Keep in mind, as you go taller, you will need to add more back wall support to your cut file. For the magnets, you can use whatever you have on hand or pick up a set pretty cheaply. I went with some strong 8x3mm magnets, where I used a rectangular grid feature in Fusion 360 to create a cut file. You can of course use the drill press to do the same holes. That said, the helix mode on the Shaper Origin makes this cutout process process really quick without any marking out required. Magnets can also be fitted equally fast with a dab of CA glue in the pocket and then a squirt of activator on the magnet. To bring the parts together, you can of course use the same method as we use with the flat cleat, or mark the edge positions on the inside of the bracket with a pencil and then carefully position the pieces with them on the bench. Again, it's up to you if you want to use pegs to secure this fitting on the wall. You are likely going to have lots of tools that will work well with a shelf setup, where we use a bracket that has a front projection and combine with a horizontal insert that is sized to the need. The size of the front projection can also be varied as needed, where we simply make adjustments to our base sketch file in Fusion 360, from which we can re-export to Shape Origin. The insert itself can be adapted to a wide variety of use cases, although broadly they're going to fall into two types. First, you have inserts where you do a cutout that is wholly within the board. These can be simple holes which will work well with screwdrivers, for example, or you can go with larger cutouts for more specific scenarios, like for example with these feather boards. This application is very secure, where you lift the tools out vertically. The second approach is where you do cutouts all the way to the edge of the board, which I did for these mallets, for example. Using this approach means you can remove the tool more horizontally, which works well for longer tools, or if you plan to place the fitting above shoulder height. If your tool handle has a taper in it, you can also make the channel slightly narrower so that a small lift is needed to remove the tool. As well as that, if the tools that you're using with your shelf have quite a bit of weight, you can add additional support with a vertical crosspiece like this. Right now I'm going to demo the to the edge method, as I want to create a new shelf for this set of bevel edge chisels. I've already got my brackets cut and my blank insert sized up, so now I just need to measure up and design a new cut file. Now, while I'm definitely no CAD expert, this kind of basic sketching in Fusion 360 doesn't take long, and in this case I was back in the shop and cutting in less than 20 minutes. Assembly is again standard glue and brads, and in no time at all the chisels are up on the wall and looking great. The fourth fitting I want to show you is a variation on the shelf specifically for storing lumber. Here I go with 18mm ply and use two brackets on each fitting, combined with a horizontal insert for extra strength. This particular bracket shape is designed to give me a 200mm front projection, which can comfortably take an 8-inch wide board. Same assembly method as before with glue and pins. Then it's a simple case of making up the number of rack fittings you need to hold your boards. For example, for a stack of 9-foot long boards, I went with 3 fittings, which is plenty strong and supportive. As with all the cleat fittings, the advantage of this approach to lumber racking over a more traditional fixed method is that you can move them around very easily. You can also temporarily add more as needed, say before a larger job. The last cleat fitting for today is the clamp rack, where you will have, I'm sure, seen variations of these following a more traditional cleat building method. This method by contrast only needs 3 pieces for each fitting, and the side pieces use less material compared to a typical triangular shape, where I can use the waste material to make up more brackets or drill for more locking plugs. We can quickly adapt the size of these brackets to work with a different number of clamps, in turn either increasing or decreasing the wall projection. The insert width can also be made up to fit each size of clamp rail. These brackets are the biggest that we've seen so far, but share the same cleat hook and lock profile. And likewise with the previous 4 brackets, these go together in exactly the same way. Hopefully that quick run through of 5 basic cleat fittings has given you some ideas and motivated you to give them a go. If you want to use this style of bracket in your shop but don't have access to CNC, then feel free to check out my Etsy shop linked down below, where I'm selling customizable kits for a range of brackets. For those of you with the Shape Origin, I've also linked to a Shaper Hub project where you can download the cut files. On the next episode in this series, I'm going to walk you through another 5 cleat fittings that are easy and quick to build using the same method. If this next episode is out by the time you're watching this, I will add a card above. If not, then a sub and hitting the bell will let you know when I publish. Thanks, and see you on the next one.